Ultimately, we want to make space accessible to everyone with the Agnikul rockets as well as with the GalaxEye satellites. ePlane, the idea here is to right now to go through eVTOLs, which are electric vertical takeoff and landing, both for cargo as well as passenger, and to beat traffic, to be able to save lives with air ambulances, transport organs across the skies. Going forward, we expect that we could actually electrify aviation itself. So one thing is to actually look at what the other people are doing and just try to copy that. Another thing is to actually sort of go to first principles and quickly derive the logic behind why other people are doing what they're doing and how electric aviation is going to unfold in front of our eyes in the next few decades, starting from eVTOL. So that actually gives me conviction that we are on the firm path of trying to change the way we fly to something that's a lot more environmentally friendly.
Namaste Bharat, welcome back to another episode of the Climapreneur show. I know बहुत time हो गया है, but we are back. एंड इफ़ यू हैव फॉलोड अस, आई नो आपने देखा होगा कि हमने भारत क्लाइमेट स्टार्टअप भी लॉन्च करा है, जहाँ पर हम भारत के अलग अलग कॉर्नर्स से अलग अलग स्टार्टअप्स की ऑन ग्राउंड स्टोरीज आप तक लेके आ रहे हैं. बट ऑन टुडेज एपिसोड आज हम लोग हैं चेन्नई में और यहाँ पर हम लेके आ रहे हैं समवन जो इलेक्ट्रिक प्लेन्स बना रहे हैं, लाइक लिटरली इलेक्ट्रिक प्लेन्स. आप शायद बहुत जल्द एक इलेक्ट्रिक एयर टैक्सी में बैठने वाले हैं. हाउ डू दीज प्लेन्स फंक्शन, ये प्लेन्स टेक ऑफ कैसे करेंगे, लैंड कैसे करेंगे, किस टाइप की बैटरी केमिस्ट्री यूज होगी. एंड इन फैक्ट he also talks about कि आप हम रॉकेट्स को सस्टेनेबल बना सकते हैं, लाइक व्हाट काइंड ऑफ फ्यूल्स कैन बी यूज्ड. सो वेरी वेरी इंसाइटफुल पर्सन वर्किंग ऑन सो मेनी डिफरेंट स्टार्टअप्स एंड आई एम 100% श्योर आज की कॉन्वर्सेशन आपको बहुत पसंद आने वाली है. सो लेट्स ट्यून इन. वेलकम प्रोफेसर सत्या चक्रवर्ती ऑन द क्लाइमप्रन्योर शो.
Thanks a lot. Thanks for having me here. Quite excited to be.
So like tell me now, personally for you, how do you define who you are? Like who is Satya Chakravarthy? What is he doing today?
Oops. Yeah, I haven't really stopped to answer that. I think definitely technology centric. So being a professor of aerospace engineering, so that's associated with technology. Been developing combustion technology before I started getting into electric planes, but also have a stint in 3D printed rockets and so on. So, but I think the more lately pursuit is to bring technology to the society and then create some societal impact. Yeah, that's kind of the approach that I'm taking in my life at the moment. So,
what all technologies are you working on at the moment?
Primarily aerospace related, but and aerospace or combustion related, but trying to democratize it, trying to make it more accessible to a lot of people. So examples that are less obvious is the rockets and satellites that we have, but ultimately we want to make space accessible to everyone with the Agnikul rockets as well as with the GalaxEye satellites. The other ones that we do are a little bit more touching lives more directly, sort of. For example, with ePlane, the idea here is to right now to go through eVTOLs, which are electric vertical takeoff and landing, both for cargo as well as passenger, and to beat traffic, to be able to position a larger throughput of cargo in the aerial route, or save lives with air ambulances, or transport organs across the skies, and or other medical supplies and so on. But we will get there. When we get there, we will actually be transporting people as well as cargo pretty fast, and so the throughput would increase, productivity of people would increase, and so on. The time savings would be there. But all of these things we do both ePlane and Hyperloop in a ecologically sustainable manner. Yeah, I think going forward we expect that we could actually electrify aviation itself with going beyond eVTOLs. So that will become like a new paradigm is what I expect. Plus we also actually have things like X2 fuels that is more pertinent to the carbon zero challenge kind of environments, where we tackle unsegregated municipal solid waste and convert it to crude oil. And that crude oil could actually then be utilized in various different ways, one of which could be to directly use it in a combustion agnostic, fuel agnostic combustion device like a Aerostrovilos micro gas turbine engine for power generation. I also have supported a hydrogen startup called NewTrace, which is now doing well. And then going forward, there are a few others that I'm actually working with, like Aerodome for like drone drone shows like what are that, swarm drones, and I'm an advisor to Neurostellar and so on. So yeah, quite a few of them.
How do you find time for all this? Like, matlab, these are so many different things, and I'm sure that because everything is R&D intensive. You have to do R&D. Then there are on ground testings that you have to do. So, how do you find time for so many diverse things? Like,
Yeah. So first of all, it's a misnomer that any one person can do anything. So in fact, I don't plan on doing all these things. The only thing that I wanted to do by myself was ePlane.
ePlane.
But in other cases, I think in Hyperloop, I did reach out to a couple of other people to come and be co-founders. So in that sense, I could have put together a team, if you will. But with ePlane, I end up doing the whole thing myself. I just want to do that at least for one product to market kind of journey before I could go out and let's say evangelize deep tech entrepreneurship. But otherwise, a lot of other startups actually have had co-founders come and walk up to me, either known or even unknown, and then we actually look at does it make sense to be doing this? Is there a decent business case? What's the pathway to this? What are the different steps that you have to take for what investments you can gain? What is the ROI that we can promise the market, and all of that stuff. So if I see a potential for societal impact at a reasonable cost, then I jump with those with it.
What makes you so passionate about societal impact?
I think that's something we need to be worried about in academia. Right. So in academia, we essentially have two strands. One is we enjoy doing our research. So it almost sounds like the society or the government, or in whichever way the larger community outside has an obligation to support us for us to do what we enjoy, which is like the research. Need not be necessarily the case. There is absolutely no reason that somebody should support my research unless they see value in it. But the other thing that we also tell ourselves is, of course, we actually put out products, which is the students, and then the students go out and do things in the society. Therefore, we contribute, and so on. But these are sort of very distant answers, in the sense they're not directly going and making the societal impact. So what I found was that if you're able to develop technologies that can be utilized by people, that actually causes a greater societal impact directly. So the thing that we have to really look at is, what is the market for what you're doing, and what is the market size that you're going after,
Right.
and what is the kind of market clientele that you're looking at, and how many number of people might actually be impacted by it. So those are metrics that actually are at the top of my mind when I'm looking at a technology that I should be part of.
Switching gears to ePlane, talk to me about ePlane, what ePlane is, and I know that you have got a very special connection to 6:53 p.m. So talk to me about that as well.
Oh yeah, okay. So you know about it. So I mean, I don't understand why we need to go back to that. But yeah, I was actually busy setting up the combustion center, and then there was this Tony Seba's video that I was watching on a particular day, October 1st of 2016 at 6 p.m. It's a 53-minute video, and at the end of it, I was convinced, with the data that was thrown there, that in about 13 to 14 years from then, which is like by the end of this decade that we are in, that the vehicles would actually get electrified. Of course, there could be a lot of qualifications about it. It could be more pertinent to cars, and it could be more pertinent to single passenger or few passenger kind of cars, or what I mean is like private use, but could be actually shared mobility as well, because he talks about it there as well. But fundamentally, private transportation. That's the segment that he was targeting, and like most Americans, I think America is the world for those people. So he might have been talking about the US, but I think a lot of what he has said has actually come to bear in places like Norway. So I think Europe is probably taking on what he's saying, but it got me to thinking, what about aviation, right? What about the way we fly? Is there a way we can electrify planes? And that was a starting point. So I still am very passionate about electric aviation in the larger sense. But another thing that I also actually speak out in public is listening to that, and then formulating my thoughts about what kind of electric planes would hit the market, and what can we do with like the very short range that we right now get with electric planes, with existing batteries that we have and all that. We were thinking about short haul mobility, like is it possible for us to go from cities to suburbs and those kinds of things, but you don't really have runways or airstrips that are so close to each other, and therefore the other option is to have electric vertical takeoff and landing. And so we were sort of configuring. So one thing is to actually look at what the other people are doing and just try to copy that. Another thing is to actually sort of go to first principles and quickly derive the logic behind why other people are doing what they're doing, and you can't escape doing the same thing. If at all, you could probably do it in a slightly different way, but that's what you end up doing anyway. So eVTOLs is what was staring in my face, which is when I also actually read this book called The Innovator's Dilemma by Clayton Christensen, which kind of gives a playbook on how electric aviation is going to unfold in front of our eyes in the next few decades, starting from eVTOLs. So that actually gives me conviction that we are on the firm path of trying to change the way we fly to something that's a lot more environmentally friendly. And also, I think, as I was saying in the morning, also easier on the pocket. So environmentally friendly solutions do not have to be more expensive on the pocket. On the contrary, innovation is all about finding economically cheaper options that are environmentally friendlier, and that's a challenge that's in front of us this decade, and going forward from then. And I think it's possible to beat that challenge fairly quickly as well.
And how do you think that like this thing scaling up to major Indian cities, be it tier 1, tier 2, even tier 3 cities adopting this technology, what do you think would be the challenges? Like, for example, when we talk about electric, obviously the battery pack size, how often do we have to say recharge, or is it like a single flight recharge? How are we going to make the batteries lighter? Are we working on different battery chemistries? So what is the thought on that?
Yeah, I think those questions were kind of like spot on. They're kind of hitting the problem on its head. So one of the first things that we realized is that we can't have a aircraft configuration that requires you to recharge after every flight. That would mean that, particularly because you're flying, you would probably get from place A to place B, which is, let's say, a few tens of kilometers apart within about 10 minutes, which is not really easy to do in an urban setting. Could be doable in a highway. You could, but even then, like for example, 10 to 20 kilometers, yeah, you could probably do it in about 10 to 20 minutes, right? On a highway, but in a urban setting, or if you want to actually go from, like, let's say, doorstep to doorstep sort of thing, you will definitely take more time on the road when compared to flying, and doesn't make sense for you to actually fly for 10 minutes and then recharge for 1 hour, right? So we have to actually worry about how many such short trips you can do in a single charge. And that's really the metric that we were going after. And I believe we probably have the largest number of trips per single charge of the battery in the world. We have actually crafted our aircraft to have that kind of a feature that makes it extremely compact. I think probably, if you didn't have this curtain, my aircraft will probably fit into this room in terms of the width. It's kind of a rectangular room. So that kind of is.
How many people can sit into it?
I'm sorry?
How many people can actually sit inside?
So we are targeting a 2-seater with a pilot in addition to them. So that means it's actually a 3-seater.
And the pilot that we're talking about, like, do we have to train these people differently, or are these pilots similar to the ones that are today flying our aeroplanes?
Yeah, so the difference in the training would actually be that it won't be as intense as the training that we go through to today's pilots. So pilots go through something like a amateur license and then a commercial license, a personal pilot license and a commercial pilot license. So this would be like a personal plus but a commercial minus. So it'll be somewhere in between, which is easier on the pocket of the one that wants to get trained as a pilot for this. In fact, pilot training today is actually expensive primarily because we use combustion-powered aircraft, and the fuel that these aircraft guzzle and the maintenance that you have to do to those engines is a significant chunk of the cost that's pushed onto the pilots that are getting trained. We believe that one way to bring down aviation costs today for the passenger will be to train pilots at a cheaper cost with electric planes. So very exciting times are ahead in that sense. But to get back to just answering your question, the pilots will have to be trained. They will have to be trained a bit more than a personal pilot license, but not as severe as a commercial pilot.
Even Uber is doing like taxis, but these are like helicopters. So why do we need, say, these taxis when we have, say, helicopters? How is it different from helicopters?
Yeah, so that's where the democratization of technology comes into picture, right? So I was just telling my wife that it's more important for us to think about how mass a scale in which we can get the technology to be adopted than to make it a very niche product that only a few people can afford to own and use. So how many people have you seen take a helicopter on a daily basis?
I haven't taken it myself ever.
Right. Good for you, because it's not a very safe option.
No, that's true. Even,
Right.
like the first thing when I started about even ePlane was because I'm scared of helicopters anyhow, considering the amount of news we see of helicopter crashes. So how do we ensure safety into, say, ePlane? And I think like when this product rolls out for masses, there might be that initial, reluctantness ki, oh my god, is it safe? So do you have a plan for it, that okay, how are we actually going to get it integrated into people's lives so that they feel comfortable?
Obviously, I mean, so a lot of these things need not be dumped on the plane designer, right? These things are actually encoded in the regulations. So the regulator insists on a certain level of safety before he can allow us to, before they can certify our aircraft and allow us to. So there is certification of the aircraft, there is certification of airworthiness for commercialization. There are a lot of steps that we have to take with the regulator, which have standards that we have to meet on safety.
And also, why just ePlanes? Why not planes being run on sustainable aviation fuel?
So the sustainable aviation fuel is probably okay for normal aviation,
But
and
not for the smaller
no,
ones?
from a economics point of view.
Okay.
Right. So question is like how cheap or expensive they are. So when we are actually doing electric planes, it's actually less about the environment. It's actually more about affordability, right? So my focus is that the environmental benefits that we get out of electric planes is actually secondary. In the sense, it's good that it is happening. It is not as if like I mean, there is no way I will actually do something that's environmentally harming anyway, right? So it's kind of like a basic checkbox that is ticked for me. But more important thing is affordability, right? So affordable is where electric makes more sense. Your asset cost is low, your maintenance cost is low, your operating cost is low. That cannot be afforded by sustainable aviation unless you're actually looking at economies of scale where you're transporting hundreds of passengers at the same time from airport to airport. So it's more meant for larger aircraft.
So, like you also spoke about electric aviation. Do you think that for the larger haul flights, like today, like when we are flying, say maybe Delhi to Chennai or even say Delhi to New York, in that situation, electric aviation is possible?
It's not possible as we see it in the near future, but that's where you need to actually go through the innovator's dilemma. So we start with any new technology, it will definitely be inferior to what we are used to. And so what Clayton Christensen, the author of that book, says is you need to actually identify a new market that the present incumbent will not be able to compete with you on, from which you actually grow and get to the point where you are challenging the incumbent. So I'm not foreseeing that I will probably make an electric aircraft that goes from Delhi to New York anytime soon. Probably not in my lifetime, but it'll get there. We will get there. But very much more sooner would be a Delhi Agra, Delhi Gwalior, Delhi Jaipur, Delhi Chandigarh flights.
And when we talk about, say, Delhi Chandigarh, Delhi Jaipur, and even with the ones that you are working on, do you think that the battery cell chemistry would stick to, say, lithium ion cell or maybe chemistries like aluminum ion batteries and all these would come into picture?
Quick answer is yes.
And what is, like, according to you, what do you think, which battery chemistry is going to be really game changer except from lithium ion cells right now?
Right. So that's a difficult question to answer. because particularly for eVTOLs. So that the problem is actually, so let's say, for example, we have cars, we have trucks and long distance air conditioned buses. Then we have eVTOLs. Then we have normal planes, the conventional takeoff planes. All of them are actually much easier than the eVTOL. The eVTOL is actually the stupidest thing short of rockets, because we are actually taking off vertically and landing vertically. We are actually challenging Earth's gravity, and that's a huge challenge to go through. The power demand during that part of the flight and the climb and the descent and all that stuff takes more power than what large energy dense batteries can afford today. So if you look at larger energy dense batteries, they don't offer that kind of power density that we would like. So I believe we will have combinations of chemistries that will manage this requirement.
What's your favorite cell chemistry?
Right now we are actually using lithium ion. There are combinations of lithium polymer and lithium ion that we could use for managing the power to energy conundrum. But going forward, it could be lithium sulfur, it could be metal air batteries, and so on. Metal air batteries, you'll have to actually crack the code on doing electrically rechargeable batteries and so on. Yeah. So there is quite some distance to cover in all of those.
And like whenever we say about electric, like one common maybe question or comment that people often have is that, okay, we're saying electric is sustainable, but till now also we are sourcing from the grid. And I think I was reading the news yesterday only that India would be putting in more coal for meeting the energy demands. And I also remember, so I spoke once with the person at the Petroleum Planning Analysis Cell, Government of India, and he told me that, Shweta, going forward, our use of coal is going to increase, but the overall use of coal in India's energy basket, that would decrease. So what is your insight on it? That will EVs ever be 100% green, or would we have to go forward with this kind of mode only where our grids are powered by, say, fossil fuels, but we are running on EVs?
Right. So, I have a couple of takes on that. One is, so the video that I talked about, Tony Seba. So, at the end of the video, he basically says all of the electricity that's required for all the electric vehicles that he sees will happen by the end of this decade will come from solar. The point being, there is enough solar capacity at the cost that's affordable for charging these vehicles is going to be available by the end of this decade. Is his prediction based on data. He has a way by which you can actually extrapolate confidently across the future, which is not so easy for a lot of other people to do traditionally. And it's very convincing. It's very simple. It just uses like log plots and all that stuff. So here lots of data that allows him to extrapolate in a straight line on a log plot where he can get very good confidence and so on. So the idea here is that going forward, we will actually be relying more and more on solar. So as you rightly said, the mix is actually going more towards renewables. I think India is doing a very good job on that mix. But you have to keep in mind that we are actually an emerging economy. We are the fastest growing, largest economy in the world. So one of the markers of the economic growth is electricity consumption. And therefore, in order to meet the power demand, including electrification of vehicles, as well as aerial vehicles that we are talking about, just want to add that aerial vehicles actually go so fast without any traffic congestion. You need far fewer electric vehicles to do the same throughput of people and as the number of road vehicles. So we believe that we will probably be not as taxing on the grid if you are thinking about the grid. But then we have to actually look at what should the grid look like. So I've had an opportunity to talk to what they call it, a DISCOM or a electricity utility company head here in Tamil Nadu. So Tamil Nadu, I found that, so when I talked to him is when I understood that Tamil Nadu actually has the curse of a developed nation. So in this part of the world, we guys are actually fairly developed in terms of industrialization and so on. So there is a sunk cost of all the transmission lines and all of that stuff that they have already put in, and they have to actually get back the money on that. Okay. Now that maybe you guys were actually a bit too soon, right? You actually tried to ape the West in doing these things. So that's where I have actually coined this word called defrastructure, right? To challenge the notion that you probably shouldn't be doing infrastructure. So the grid problem is actually an infra problem, not a electricity generation problem. Okay, when you now say more coal and all those things, it's actually going towards electricity generation. Allow people to generate, right? You put solar panels on all rooftops, get the generation to happen, and electricity generation and transmission distribution companies that are state-owned should actually change to electricity management companies. Their job should actually be to just manage the grid, right, and get people wean off the grid as much as possible, right? You should essentially give like a backbone support from the grid for people to transact like very small units of electricity, right? They get their power, they just can't be sure that, see, particularly we are dealing with AC.
Right.
The problem with AC is that you generate, you have to consume right away. Right, yeah, move to DC, right? So who is asking you to do AC? It's all like some 20th century stuff. It's all some 100-year-old stuff. Move on. Let's actually get to a different paradigm of electricity. Don't actually stick to something old and then say that we are actually posing a problem, right? You actually figure out a solution. There is a solution. It's not as if like solution doesn't exist. The problem is a sunk cost effect, right? Electricity companies have put in money and then they don't want to change now, right? You have to actually question the government on this.
But that is an interesting perspective, because I never thought like that, like how they want to recover their money, and that's why probably
Yeah. It's the world over. It's nothing to do with Tamil Nadu, nothing to do with India. It's a world over problem.
Yeah. But that's very interesting.
So, which is fair actually. People who are less developed, right, in our parts of the world, in different parts of India as well as parts of Africa and so on, they are better off because they are actually in a much better position to embrace new technology.
I agree, just a few weeks ago, I was in Sundarbans and we were doing an on-ground story there on communities and how they're doing mangrove plantation. So to reach Sundarbans, you have to take like a 2-hour boat ride, and while we were going there, I saw a house with a solar panel. And honestly, so you won't believe that at that place there are no teachers available because no one wants to travel 2 hours by boat and teach students. Food comes, I think, once a week or twice a week, and again by boat, because road connectivity is not there and whatever is available is not in a very good condition. So I asked the local boat guy that how is the solar panel installed here, and he said, because ma'am, in cyclone times the houses are made of mud, even the house flows away, and if it doesn't, electricity goes away, and these people have no choice, and that's why they have installed solar panels. I was so surprised that how the community has embraced this technology.
Yeah, I mean, just to give you a different parallel. So we are now convinced that electric air taxis are actually going to be much more useful in India than anywhere else in the world.
True.
Right? Because in this part of the world is where traffic congestion is actually the highest. The less developed world is the one that is actually going to leapfrog with latest technology because the absorption capacity for them is much higher. People who have already got entrenched in the older technology are going to be the laggards.
And I think just because you reminded me of Sundarbans, people there, if this taxi launches there, I think it would be life-changing for them. Because like the guy was mentioning, ma'am, if something happens to our people, like maybe if a tiger also attacks, hospital is like you have to go by 2 hours by the boat, and then you have to travel to the hospital. Like yeah. So I think these taxis there would be game changing.
By contrast, it also takes 2 hours to actually wait through traffic to go to the nearest hospital.
Correct.
Over here. In an urban setting with so many hospitals around. It's such an irony, right? Yeah. So air ambulances is something that's a huge thing for us. Yes.
But really looking forward, and like now switching gears to space, because you said that we need to make space accessible for people. Do you think that can really happen sustainably? Because like I think read somewhere on sustainable cryogenics and how today these space, maybe even NASA, ISRO, and also Indian space startups who are coming up, they're also looking for sustainable ways to launch rockets, sustainable combustion. So what is your take on that?
I think there is a way by which we can go to clean combustion. So hydrogen combustion is definitely one of the cleanest, and short of that could actually be methane combustion, and we can do things like what's called as methalox, that is liquid methane and liquid oxygen. So those actually emit much less carbon dioxide and are greener on the planet. In fact, I think the motivation that Elon Musk had in trying to do the liquid methane and liquid oxygen was to make sure that he doesn't pollute Mars when he wants to go there, and that's actually very ironical again, because the Martian atmosphere is full of carbon dioxide anyway, right? So some of these imagined problems that we try to solve turn out to be good for our planet, right? So yeah, I think that's a direction in which rocketry will be going.
And like we also see that all the images of the earth that we see online, and today we have got so many satellites surrounding satellites which are not even working, so what do we call as waste? So
Debris, space
yeah,
debris.
so what can be done about it? Is there a solution that today exists about it?
I think there are two things that are being done. One is the smarter thing to do immediately is to make sure that we don't accumulate any space.
And
So,
how is that possible?
there are protocols for us to deorbit the debris
Okay.
so that we don't accumulate it over there, but actually get it to come and plunge through. In fact, it will disintegrate as it re-enters the atmosphere into much, much smaller pieces and burn up. And whatever little remains could actually get into the ocean or something. So, but it essentially kind of spreads out into the atmosphere and disappears, sort of. Yeah, that's actually what's now in place, that we will not accumulate any debris anymore. There are some efforts in trying to clean up the debris that we already have. At the moment, I think the amount of debris that we have is still manageable. Depends on which orbits that we are targeting. I think in the past, people were actually looking at middle Earth orbits and geostationary orbits that are much farther and so on. But there is going to be a lot of crowd for the low Earth orbits in the next couple of decades, and that's where the debris problem will become a lot more. Then, because as you go farther out, you have like much larger space across which the debris gets distributed, which is okay. The density of debris is the real question, and low Earth orbits pose a challenge there. So that's where this protocol is important for us to deorbit these debris once we have used the satellite at their end of life.
And is there a way in manufacturing satellites, has it changed, like the one way we used to do it earlier to now, like our satellite manufacturing also getting sustainable with the materials we are using, with the processes we are following? Has there been any changes into it?
Significant change is actually in the size of the satellite itself. So satellites have now got a lot smaller for doing the same job or even better. So the payloads are much lighter, and the rockets that are needed to actually put them for targeting a certain use are getting smaller, and therefore the fuel that we will burn to get there, particularly to just a low Earth orbit, is lesser. So even though the satellite material may not have changed, since the size has changed and the weight has decreased, that is better on the environment.
Thank you so much for sharing this, and thank you so much for being on the show with us. Like, I genuinely enjoyed talking to you. I genuinely enjoyed all the information you shared, from different kind of fuels that we'll be using for rockets to different kind of cell chemistries. And I'm so excited to see the plane up and working, and especially how it actually changes lives, because ultimately for me, I feel that climate technology or climate solutions have to enter the zone of comfort and convenience, and it has to really impact the local people, because that is when the benefit of technologies will be visible.
Yeah.
So thank you so much for being on the show, and thank you for doing this.
Thanks a lot for having me here. Enjoyed it.
Thank you.